Hello, statistics student. This video is for chapter 4.2, application of probability distribution. And in this case, it's actually discrete probability distribution. So the probability distribution table that you run into, they're usually in like X, you have a column of X, and then you have a column of P of X, like that. But actually, you can also do a probability distribution to analyze a game. When we say a game, it could be a gambling game. It could be just a card game or anything. And then for gambling, you win money, you lose money. So, and then it could be a business, like say buying an insurance, an insurance company, all those things. So probability distribution is actually very useful if your x value is happened by chance and you know the probability, and these x value are monetary value because of a gamble on a game or because of a business. And then if you can build a table like this, then you would have X is the long-term net gain after a bet because of a game or a profit for business. So this X can be negative, could be positive. Negative means a loss, and then positive means a gain or a profit. E of X is the expected value of the game or the business after constructing a probability distribution. So we know that if you play a game, you gamble, sometimes you win, sometimes you lose. But on average, if you play it a lot of time, on average, what would be the outcome? So being able to build a probability distribution and also find expected value help us to analyze the average. And you can use it to compare two businesses, or you can compare two games, see which game actually gives you a better chance of winning. And actually, the casino actually monitor these XP of X value so that it is to their benefit. Example one, suppose you play lottery where the chance of winning is 0.0001. So it's very low chance of winning. They tell you this already. And you need to pay $3 to play. So if you are to enter the lottery, you have to pay $3. So, and then if you lose, then you forfeit this $3 gone. So you could have a loss. Okay. If you win, then you collect $10,000. So is this a good game to play? What is the expected value of the game? So first of all, we need to look at how to build this table. So the way this table is built is not just X and P of X. You would associate it with an event. And the event, because it's a game, is always win or lose. If you win, the X value is the monetary net profit or the net gain. So X is the gain positive if you lose or win. So they should only have two entry. Event is either win or lose. If you win, you do not win $10,000 because you pay $3 to play. So the your net gain is actually, I calculated here. So the net gain of winning is 10,000 minus $3 is 9,997. And if you the probability tells you that the chance to win is 0.001, so what's the chance of losing? That you did not win anything is 1 minus 0.001 is 0.9999. So once you have all these number figure out, then you will say, oh, if I win, my net gain is 9997. My net gain for losing is I lose the $3 of the bets. What is my probability of winning? Probability of winning is 0.001 is given, and losing is 1 minus this number is 0.999. So then what is E of X? Of course, you can put it into the easy calculator to do, but it's a little unnecessary because you only have two entries. So if you want to, we can try it, but I would just do XP of X and add them together. So basically you multiply these two together and then you multiply these two together. Now be careful of the negative. You actually have to enter a negative. Oh, for the sake of demonstration, maybe I'll just do that. 9997 and then 0.0001. Let's see. We say we only have two entry, right? Two outcome. The two outcome is not counting anything, but it's the money that you earn. This is not an occurrence, but it's the money that you earn is 9997, but you only have chance of happening is 0.0001. Can we do negative? I don't know. -3 because you, oh yeah, you cannot do negative. Oops, can you do 3 and then negative? No, -3. Oh yeah, so you cannot do that by this calculator. Excel can do it, but it's a little difficult to teach that. So you only do it by hand. So you do 9997 times -3. Well, we can use a decimal calculator to do, right? Instead of doing this, we would use decimal calculator, and then there's a scientific calculator here. So you do 0.0001 winning times 9997 plus -3. -3, I think you just do this -3 times -3 times what? You lose $3, right? No, lose $3, but it's 0.000. No, right. So this is X. Did I? No, I think I got it wrong. You win. If you win, you have 9997. X times P of X is 0.0001. And then if you lose, you would have -3. But the probability of losing is really high, 9997, right? So is no 0.9999 because the probability of winning is 0.0001. The probability of losing, we do it earlier, was 1 minus 0.0001. Okay, so 1 minus 0.0001. Yeah, it's 0.9999. So in a sense, you actually just multiply this and multiply this, right? Multiply this and multiply this. So it's -2. It's -2. Negative means you lost. You will every time you play this game, you lost $2. In the long run, the expected loss per game is $2. If you play 10 times, you potentially can lose $20. And casino is using this to keep track. So how do they know this P of X? They usually do it by relative frequency. So they actually check how many people are winning, how many are losing, so they would know the table. So another game is you bet $5 on number 7 and roulette. Roulette had a 36 number, right? I like to play this in the casino. It's very easy to play. You can play red or black, right? And then you can lose everything in one shot and go home. Um, whereas if you play blackjack, you can stand there for hours and not going home. So it's very hard to lose in blackjack from my point of view. So so there's numbers here, so you can say 0, 1 to 36, right? So that's 37 number, and then there is a 00, which is not you're not supposed to buy. Is the host will win if it's 00 will win everything if the host is 0. So there's 38 different things that you can do. And then, so to lose is they open not 7, right? So it's 37 over 38. To win is the boss stop at 7, so it's 1 over 38. If you win $175 because you collect $180, I guess, because you collect. Oh, maybe I'm not very clear here. You collect 180 when you win. So the net profit is 175. But if you lose your $5 bets. Okay, so actually I do X times P of X here. And then after that, I add them together. So it is -0.26 or 26 cents. So for every $5 bet, you expect to lose an average of 26 cents. The more you play, the more you lose because it's negative. Okay, so this is also a good way. You multiply these two numbers together, round it to this, and then 5 37. Yeah, let's try. Yeah, so you can do it that way. So sometimes your probability, you have to figure it out yourself. Example 3 is insurance. Okay, so insurance is not a game. You buy an insurance to make sure that if you die or something happened to you, you get a uh, uh, policy insurance pay, so it can cover your loss for your beneficiary, right? So a 25 years old male passed away within the year is 0.0005. Why do they know that? This is called a life table. A life table that all government and also all insurance company keep. They keep track of for at a certain age, what is the probability that that person will live through the year. So it is pretty valid. It's actually a population. They don't do a sample. They actually collect a lot of data to produce this. Is very accurate. Then because to protect whatever the obligation that he need to support, he paid $275 1 year's 160,000 life insurance policy. What is the expected value of the policy from the insurance point of view? So you would sometimes that person die, right? So there's two events, person that die, then the insurance company lost a lot of money. Kind of like the fire. If there is, you buy a fire insurance, if there is a fire in your house, the insurance company lost a lot of money. But if you don't die, you live on, then the insurance company take your whole insurance premium, which is $275. So this is what they have. And what is the probability of living? Probability of living is 1 minus 0.0005. So this is the probability of dying. Probability of living would be 1 minus is complementary. So you have the P of X like this. This P of X is related to living, and this P of X is involving dying. But you would use this X and P of X to calculate the expected value. So the expected value would be X times P of X. You can actually do a value here, but I'll just do the whole thing here. 275 times 0.9995 plus negative 15925 times 0.005 is 195. If you want me to show you the step on how to do it, it would be like here. So this way, what was it? 275, right? So 275 times 0.9995 is a high chance that you will live plus negative 159725 159725 because you have to, well, actually it is negative here, not negative 1. Negative 159725 because the person died. And what is the chance of this? 0.0005. And you can see that it's positive 195. It's positive from the point of view of an insurance. Okay, the insurance will not collect 275 because some people actually die, so they only gain $195 from you if you live on. And so per policy, they will gain 195, so it is to the advantage that they sell as much as possible. So that is all these are the application of probability distribution tables in business as well as in game.